Thanks for coming, everyone. I apologize if I look a little worn out. I just carried like 30 pounds worth of t-shirts over from the Bellagio. A little heavier than I expected, but they're here for you guys afterwards, so please come and get them after. Anyway, welcome to Punk Code, hiding shell code in plain sight. I'm Michael Sutton. This is my colleague, Greg MacManus. This is a piece of research that actually stems back to work that Greg had done back in 2002 when he was looking at exploiting web browser vulnerabilities. We've certainly seen no shortage of that lately. You know, we just finished the month of browser bugs that H.D. Moore gave us. So we've seen a lot of it, but when you're exploiting that type of vulnerability, as when you're exploiting just about any vulnerability, one of the challenges that you face is getting your shellcode, and likely your NOP sled as well, into memory, and then being able to find it. There's various techniques for doing that sort of thing. They have their pros and their cons. And one of the things that Greg thought of was, you know, why use one of these techniques? Why not use something that we know is going to be in memory, and that's the images that are loaded by the web browser themselves. But wouldn't it be cool if we could take that one step further and still keep those as images, so that they are a legitimate image, that if when somebody views it, it wouldn't arise any suspicion. So that's the purpose of this. We both work for iDefense Labs. It's a division of VeriSign, and the basis of what we do is vulnerability research, and that's where this came up, because you know, part of that is finding new and interesting exploit vectors. What we're going to go over today, we'll start off with just a very brief history of shellcode. It's important to understand why you would even need a technique like this in the first place. And then we'll get into what punk code is, how it works, what the methodology of it is. Punk code is not a thing. It's not an exploit, as Greg will explain. It's a methodology. It's a theory. But then we'll put that into practice. We'll discuss sort of how different images are created and how we can leverage that for our purposes. We've built some tools to make the theoretical practical. Those are actually up on our website right now, labs.idefense.com. Go in the software section, you'll see it, PunkGUI and JPEG-POC. We'll then sort of get into a little bit of theoretical about some other file formats that we haven't completed research in, and then talk about just some of the implications, both offensive and defensive, that arise from this sort of research. So here's my brief history of shellcode and buffer overflows. Buffer overflows have been around forever. It's not a new thing. They kind of came to light for a lot of people when Aleph1 did his paper on smashing the stacks with fun and profit. And looking back, it's a pretty basic scenario, but it taught us the basic steps of what this is all about. Aleph1 taught us what a stack-based overflow is. He taught us that we have to get our shellcode into memory, and in his case, he was using an environment variable to do that. He taught us that it's a whole lot easier to find our shellcode when we use a no-op sled in conjunction with it. And he also taught us that there's some challenges that we face. In the case of these simple overflows, it was that we couldn't have null characters, or we couldn't usually have null characters in our shellcode. And then lastly, he provided us with some basic code that took care of that, took those null values out. The vulnerabilities that were discussed in Aleph1's paper, those were local vulnerabilities, not that exciting. You know, most people, they're more interested in researching remote vulnerabilities, and that adds some additional complexities. We don't have as much control over the remote machine. We can't tell that remote application what to start up in memory, what to use as its environment variables. We also may have limited buffer sizes. And it's not just null bytes that we have to worry about. There's other things. If we're going in through a web-based interface, you know, we may be limited to using alphanumeric shellcode or Unicode shellcode, things of that nature. And lastly, then there's IDS evasion issues. You know, there's always this arms race that we're all aware of. The bad guys do something, the good guys do something, and IDS is part of that. The IDS signatures get smarter and smarter and look for things like simple no-op sleds. Where are we at today? Much more advanced state of affairs. H.D. Moore is speaking in one of the other rooms right now on Metasploit, and even the current production version of Metasploit 2.5, it already gives us 25 different payloads, 9 encoders. We're not talking about just launching a remote shell. We're talking about things like injecting a VNC server. So there's some pretty cool stuff. We also have tools that allow for automatic shellcode generation. And they take care of those encoding issues for us, because we have decoder stubs that can decode and that can encode and decode our shellcode to get around some of these issues of limitations on what we can use. And lastly, we have fancy no-op sled generators, so that we're not just sending a simple stream of 0x90s, because those things are looked for, so we can be creative in what we send.
So what is pun code, and how does that go in with all this? Well, pun code is a pun code. It's a pun being a play on words, and yeah, this is the same sort of thing. Basically, it uses the von Neumann architecture feature that data and code are indistinguishable to the computer. It depends on what you tell the computer to do with it. If you throw it at the screen, it becomes dots of colors. If you tell the computer to execute it, it becomes instructions to execute. The picture on the right is an image generated from an executable file. Basically, I just put an image file header on it and told it to display it. The code for that's on the left. Pun code is not a vulnerability or an exploit. It's just a method of putting the shellcode into the program. The code won't run without a way of actually calling it. And you can prevent being exploited by this by using hardware debt. I mean, but that's the same for pretty much anything which will which puts the shellcode on the heap and tries to execute it. So you need to make sure that's enabled and the current program isn't on the excluded list, and that the memory permissions of whatever segment it loads the images into don't allow it to be executed, and then it would stop the thing. So pun code is actually a play on bytes. It makes images which are visual puns. They're entirely composed of a no-op sled and shellcode. They load directly into your browser. The tools that we're releasing allow PNG and JPEG format, and I've also done GIF format stuff. They look pretty much like a normal picture, and it's only slightly more work than embedding the shellcode into a large image file to get it into memory. You'll see what I mean, I think, when I show you by slightly later on. Yeah, we actually have exploit stuff that works with this. The first stage of research on this was back in 2002, not long before I started working for iDefense. I was looking at Netscape 6. They offered a browser bug bounty, a bug bounty of $1,000 for code which led to execution, for bugs that led to execution of code. So that was a good motivator. The code you see, the image you see on the right there, it's the stripes. Are some jump instructions, which basically, because most of the vulnerabilities I found were heap related, it was to jump over any of the corruption that occurred. First dark gray band there is to avoid is to stop, so it's something to jump into, so it doesn't jump partway into the code. And the colored stripes themselves are the actual shellcode. Because each line's exactly the same, it makes the stripes. So yeah, the question in the initial version was written down, so was, how can I find my shellcode? When I was exploiting these vulnerabilities, I found that the web browser could be in any state at all. You didn't know where your code was going to be. It could have been running in any one of a number of threads. It could have started at any point. It depended on, were you loading a page in the background? Had you checked your mail in the last 10 minutes? I thought, well, how can I make the program use one fixed place? So, with the way the malloc works is once a certain threshold is reached for the size, it uses mmap to allocate a region. And if you make the region large enough, it tended to be in a predictable space. It would one of the return addresses I could just use any return address which was in that range. So the way pun code works is you choose an image, you scale the image up a lot. So you want to make it take up a lot more memory because that gives you a lot more target to aim for. You convert the whole image into a no-op sled. Basically, you map each byte to a valid instruction, which doesn't do much. Then you embed the shellcode in it, somewhere where it's not too obvious, and you convert this into the final format. Certain compression caused by certain formats can damage the code, so you need to do some other tricks. So why would you want to use this method over, say, the Skyline's heap spraying method? His method fills a heap with a log run of 1 byte, which is the OD, followed by the shellcode, and then the exploit runs. The OD byte can mean a few things. It can either be the instruction or EAX OD, 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 which doesn't really do much except modify what EAX is. Or it can be a pointer to a memory address, which happens to be self-referential. So it's a safe address to reference, and it's safe to be dereferenced. So many workarounds for vulnerabilities only stop the exploit. Disabling JavaScript, well, it'll only stop JavaScript-based vulnerabilities. If the vulnerability is in another part of the code which doesn't require JavaScript, then you could use a different exploit method. It would prevent the Skyline heap spraying method, but it wouldn't prevent this method of putting the shellcode in memory.
Yeah, as Greg mentioned, what we're doing is we're taking that image and we're turning it into a knob sled, but in doing so, we still want our image to remain as intact as it can. So the starting point was figuring out what instruction we can use, because we want to have bytes which are valid instructions, but at the same time, they also represent the pixels in the image that we want. So we had to first go through and say, what do we consider safe instructions versus unsafe? So anytime I keep referring to a no-op sled, and I'm probably referring to it in a sense that you don't normally think of it in, because we'll consider it a no-op as long as it doesn't affect code execution. So for example, a typical no-op is O by 90. But then take, for example, something like O by 42, increment EDX. That does something, it has a purpose, but for our purpose, that's a no-op, because it's not going to redirect the execution of our code so long as we're not relying on that particular register. So we have a much broader interpretation of what a no-op is, and that's important for us because the more bytes that we can use which are valid, the more accurate we can make our picture. There are, however, some things that we can't use. They're going to be unsafe instructions, things that require a usable stack like push, pop, call, return, anything which dereferences a register, and privileged operations. So we're never going to be able to make a perfect picture. It's always going to look like it's been degraded slightly because there's certain pixels that you just can't touch. So let's divert for a sec and talk about psychophysics. What the heck is psychophysics? According to Wikipedia, it is a subdiscipline of psychology dealing with the relationship between physical stimuli and their perception. What the heck does that mean? It just means the way we perceive things may be different than what they actually are. Think of when you go to the swimming pool. You go and you sit in the hot tub, it's nice and hot, feels really good, your body gets all warm. Then you get out and you run and you jump in the swimming pool. It feels ice cold. Is it really ice cold? No, it's so different than what you were just in. The same thing happens with images and what you look at. Depending upon the context of what you're looking at, you may interpret it differently than what it really is. That's important to us. You're not seeing the details. You're seeing the forest, not the trees. And that's good because it allows us to fudge things. It allows us to be a little less detailed without changing the overall picture. Go a little deeper. The eye is pretty forgiving. You can make little mistakes in a picture and they're not that noticeable. For example, if you have some pixels that are off color but they're really small, that's less likely to be noticed.